Hey, how you doing? Today we're going to continue our study on radical expressions, and we're going to focus on multiplying them. And so we'll see what that looks like here. I have a couple examples on the board, and this one here is I have 4 times the square root of 12 and 3 times the square root of 20. Now, the square root of 12 and the square root of 20 are not perfect square values, so we can't really get their exact value by using a calculator. We can just simplify them to its simplest form. Now, you can do this either prior to multiplication or after. I like to do it prior if it's possible, and let me show you what I'm talking about. In this one here, we have the square root of 12, and we can simplify the square root of 12 by thinking what perfect square goes into 12. That would be 4. So I can rewrite the square root of 12 as the square root of 4 times the square root of 3. Now the square root of 4 is 2. And so what this problem really becomes is this 4 times that 2 times the square root of 3. Now, that much is going to be 8. So this problem is the same as 8 times the square root of 3 times whatever we get over here. Now, the square root of 20 is not a perfect square, but the square root of 4 times the square root of 5 is equivalent to the square root of 20. Now, it has this 3 on the outside, so we need to take 3 times the square root of 4, which is 2 again. And that would give us 6 times the square root of 5. So this problem is equivalent to 8 times the square root of 3 times 6 times the square root of 5. Now, the numbers on the outside, 8 and 6 get multiplied together. That gives us 48. And the numbers on the inside or underneath the radical would be 3 times 5 or 15. So we end up with this being our answer as 48 times the square root of 15. Now, you should always look to see if you can simplify the square root of 15. Because if you can, you'd want to do that a lot like what we did here with this square root of 12 and 20 as well. Now, you could wait to simplify later if you wanted to. So another option would be to multiply 4 times 3, and then you would have 12, and then 12 times 20, or the square root of 12 times 20, would be the square root of 240. Now, we would need to simplify the square root of 240 like we did earlier here to finish this problem. But we'd still end up with 48 times the square root of 15. Now, another thing that we're going to be able to do with these things is sometimes we're asked to FOIL or multiply 2 binomials together. And I have an example of that over here. Here I have 2x plus the square root of 3 times 6 minus the square root of 2. And I mentioned FOIL. We're just going to multiply the first outside, inside, last to these values here. So I like to draw arcs when I multiply those. So I'll take 2 times 6, and that gives me 12. And 2 times the square root of, well, the negative square root of 2 would be negative 2 square root of 2. I'm now ready to do the inside, because I did the first and the outside. Now I got the inside of FOIL, the I part. Square root of 3 times 6 would be 6 times the square root of 3, positive. And the positive square root of 3 times the negative square root of 2 would be the negative square root of 6. Now, if I look at those 4 terms right there, none of those are like radicals, and so I really can't do anything more than leave this expression like it is. Sometimes these radicals can be simplified to where you can add them together, and we did that last time when we talked about adding radical expressions together. This one you're not able to do. Now, there's an interesting thing that happens when you multiply conjugates together. And conjugates are things like this. Like where I have 1 minus square root of 5 and 1 plus the square root of 5. They're basically the same numbers, but with opposite signs. And what happens is an interesting thing occurs when we multiply these two things together. So if I FOIL these, what happens is this. If I take 1 times 1, I get 1. 1 times square root of 5, I'd get plus the square root of 5. And so I've done my inside, my first and my outside terms, and I'm ready to do the inside terms of FOIL. And I would end up with negative square root of 5 times 1, which is negative square root of 5. And negative square root of 5 times positive square root of 5 would be the negative square root of 25. Now, notice what happens. These two middle values, positive and negative square roots of 5, they cancel out because they're opposites. And the square root of 25 is 5. And so what we have here is this is 5. And so the denominator, or not the denominator, but the question just becomes 1 minus 5 or negative 4. Okay? So, and what that really illustrates here, this 1 minus 5 in that expression, is really the same as the difference of two squares rule. We have been working with factoring, and we came up with something that's called the difference of two squares. And when we had a square minus a square, we could factor them into the square root of the first plus the second, square root of the first minus the square root of the second, like we did here. And so now we're kind of going in reverse order. If you look at this, 1 squared minus the square root of 5 squared would be 1 minus 5. So once you learn this shortcut, it's pretty nice. Now, I'm going to apply that shortcut when we divide. When we divide radical expressions like this, we actually multiply. But we multiply top and bottom of this fraction by the conjugate of the bottom. Conjugates are these guys. Same expressions with opposite signs. So the conjugate of 3 minus the square root of 2 would be, the conjugate of 3 plus the square root of 2 would be 3 minus the square root of 2. So I'm going to multiply top and bottom of this fraction by 3 minus the square root of 2. Now, if you just focus on the denominator, we have conjugates together. If we apply this rule here, in my problem, my x is 3. So 3 squared minus my y value is the square root of 2. So I would end up with this. 3 squared minus the square root of 2 squared. Now, anytime you square a square root, you get the value on the inside of that. So the square root of 2 squared would actually be 2. And so my denominator of this fraction becomes 9 minus 2, or 7. So 7 is now my denominator. Now my numerator of this, I need to distribute this 4 times the conjugate of the denominator, which means I take 4 times 3 and I get 12. And 4 times the square root of 2 would give me, actually it would be minus square root of 2, would give me 4 times the square root of 2. And I'd have this expression as 12 minus 4 times square root of 2 over top of 7. These problems all have something in common. They involve multiplication of radical expressions. And I hope this helped you, and I hope you come back to see me sometime.